My dear students, in this video I am going to solve a problem in the topic mathematical induction. That is, I am going to derive one mathematical result by using induction principle. The problem is, prove that 1 square plus 3 square plus 5 square plus etc. plus 2n minus 1 square equal to n into 2n minus 1 into 2n plus 1 by 3. That is, sum of the squares of the odd natural numbers. Sum of the squares of the odd natural numbers. 1 square plus 3 square plus 5 square. Odd numbers only. Odd natural number square, where n is a natural number. Positive integer. Natural. N is a positive integer. 1 square plus 3 square plus 5 square plus etc. plus 2n minus 1 is an odd number. Nth odd number. Square equal to n into 2n minus 1 into 2n plus 1 by 3. That's what I have to prove. You know the induction principle. The step 1 is initial step. That is, we have to prove that the result is true for n equal to 1. We will consider the given result is by P of n. The entire problem is given that P of n equal to 1 square plus 3 square plus 5 square etc. 2n minus 1 square equal to that. Left hand side is this, right hand side n into 2n minus 1 into 2n plus 1 by 3. Our initial step is, we have to prove that, first step, we have to prove that the result is true for n equal to 1. That is P of 1. Left hand side, P of 1 equal to, left hand side, P of 1 equal to 1 square, that is equal to 1. N equal to 1 means n equal to 1, P of 1. P of 1 is 1 square. 1 square is 1. Right hand side, n is 1. 1 into 2n minus 1 into 2 into 1 plus 1 by 3. Because n is equal to 1. That is equal to 1 into 2n into 1 is 2. 2 minus 1 is 1. 2 into 1, 2. 2 plus 1 is 3. By 3, 3 cancel. You will get 1 into 1 is 1. So right hand side is also 1. Left hand side is 1. Right hand side is also 1. LHS equal to RHS. Therefore the result is true for n equal to 1. We have to prove that the result is true for n equal to 1. Where n equal to 1, P of 1 is 1 square is 1. Right hand side 1 into 2 into 1 is 2 minus 1 is 1. N equal to 1 is 2 into 1, 2 minus 2 plus 1 is 3. 3 by 3 cancel. You will get just 1 into 1 is 1. Right? LHS equal to RHS. Therefore, the result is true for n equal to 1. This is the first step. Second step is induction principle. Induction step. That is, we assume that the result is true for n equal to k. Second step is, we assume that the result is true for n equal to k. That is, P of k equal to, we are assuming that the result is true for n equal to k. P of k equal to 1 square plus 3 square plus 5 square plus etc. plus n equal to k. If you substitute 2k minus 1 whole square. If you put n equal to k, 2k minus 1 square equal to, right hand side is k into 2k minus 1 into 2k plus 1 n equal to k by 3. So we assume that the result is true for P of k. P of k is k into 2k minus 1 into 2k plus 1 by 3. Right hand side is that, left hand side is 1 square plus 3 square plus 5 square equal to etc. equal to 2k minus 1 square. We assume that the result is true for n equal to k. This is the assumption. And we have to prove that the result is true for n equal to k plus 1. We will see now. Okay? See, in the second induction step, we assume that the result is true for n equal to k. That is 1 square plus 3 square plus 5 square etc. plus 2k minus 1 whole square equal to that. K into 2k minus 1 into 2k plus 1 by 3. We are assuming the result. And we have to prove that the result is true for n equal to k plus 1. This is our induction principle. We have to prove that the result is true for n equal to k plus 1. Assuming the result is true for n equal to k, and we have to prove that the result is true for n equal to k plus 1. Assuming the condition. So you get p of k plus 1 equal to what we have to prove? Instead of k, we have to prove right hand side is, if you put k equal to k plus 1, n is k plus 1, and here 2k plus 1, 2 into n is k plus 1 minus 1, n for k plus 1 into 2 into n for k plus 1 plus 1 by 3. That's what we have to prove on the right hand side. Then is k plus 1 into n is k plus 1. 2k plus 2 into 1 is 2. That is 2k plus 2 minus 1 is 1. 2k plus 1. Because 2 into k, 2k plus 2 minus 1 is 1. Therefore 2k plus 1. Similarly, 2 into k, 2k plus 2 into 1 is 2, 2 plus 1, 3 by 3. That's what we have to prove. This is what we have to prove on the right hand side. If for n equal to k plus 1, p of k plus 1 means k plus 1 into 2k plus 1 into 2k plus 3 by 3. Instead of k, then you can substitute k plus 1. We will check whether the result is true by applying the left hand side. Left hand side is what? This is your right hand side. Left hand side is 1 square plus 3 square. 1 square plus 3 square plus 5 square plus etc. plus 2k minus 1 whole square. This is k. And next step is k plus 1. 2 into k for k plus 1, n for k plus 1 minus 1 whole square. This is our left hand side. 1 square plus 3 square plus 5 square etc. plus 2k minus 1 square up to k. This is p of k. Plus, instead of n equal to k, you get 2k plus 2 minus 1. 2k, this is up to this p of k. Up to this p of k plus this is 2 into k, 2k into 2 into 1, 2. 2 minus 1 is 1. 2k plus 1 whole square. This is your final step. P of k is up to 2k minus 1 plus 2 into k plus 1 minus 1 square is 2k plus 1 square. This is your left hand side. We will see. You know, up to p of k, what is the result? You know, this is p of k. K into 2k minus 1 into 2k plus 1 by 3. This is p of k. Up to this, you get p of k. K into 2k minus 1 into 2k plus 1 by 3 plus k plus 1 step plus 2k minus 1 whole square. 2k plus 1 whole square. That's left hand side. Okay. Up to this 2k minus 1 p of k. P of k result you know. K into 2k minus 1 into 2k plus 1 by 3 plus 2k plus 1 the whole square. This term becomes 2k plus 1. Now to simplifying this, we are going to take 3 as LCM. In this step, we are going to take 3 as LCM step, common LCM, that is k into 2k minus 1 into 2k plus 1 plus 3 into 1, 3 into 2k plus 1 whole square. Okay, after taking the common denominator 3, you have to multiply the second term with 3. 3 into 2k plus 1 whole square by taking the common denominator 3. In this case, numerator you find 2k plus 1 as a common term. In these two terms, you can find 2k plus 1 as a common term. Therefore, the remaining term is k into 2k minus 1 here. If you take 2k plus 1 common term here, you get k into 2k minus 1 the first term plus here. In the second term, you get 2k plus 1, you can take a common term, another 2k plus 1 the square, you get one more 2k plus 1 term by the common denominator. So by taking 2k minus 1 as LCM, here k into 2k minus 1 plus 3 into, after taking one 2k minus 1 in the square term outside, you will get only 2k minus 1 in the bracket. So therefore, differential again. K plus 1 into 2k square minus k, 2k square, 2 into k, 2k square minus k into 1 to k plus 3 2s are 6k plus 3 into 1 3, 6k plus 3 into 1 3. By common denominator 3. So again you will get 2k plus 1 into 2k square plus 6k minus k, you will get plus 5k plus 6 minus 1k, you will get plus 5k plus 3 by 3. This is. Now you can factorize that 2k square plus 5k plus 3 into two factors. What we will get, we will see. Okay? Now factorizing the second term 2k square plus 5k plus 3 only will take, see, 2k square plus 5k plus 3. On factorizing you will get 2k square plus 2k plus 3k. 2k plus 3k, 5k, 2 into 3, 6k square. If you multiply last above, first and last time you will get 3 2s are 6k square, multiplying 6k square. You split this 6k square into 2k plus 3k. Adding these two you will get 5k, multiplying these two you will get 6k square. 2 plus 3, 5k middle term, 2 into 3, 6k square. This is the factorization method, you know. Therefore, 2k if you can take common, k plus 1 plus 3. 2k plus 3k plus already 3 is there. Again you will take 3 common, you will get k plus 1. In both these terms you will get k plus 1 as a common term. You will get 2k plus 3. So the left-hand side becomes, now after factorizing, left-hand side becomes 2k plus 1 into factors of these two becomes k plus 1 into 2k plus 3. The denominator term is 3. See, this is same as right-hand side. Right-hand side take k plus 1 into 2k plus 1 into 2k plus 3 by 3. You can rewrite this as to first to bring this k plus 1 first term, product term, k plus 1, 2k plus 1 into 2k plus 3 by 3. See, left hand side k plus 1 into 2k plus 1 into 2k plus 3 by 3 denominator. Therefore, left hand side equal to right hand side. Therefore, the result is true for n equal to k plus 1. Therefore, I am going to write here conclusion. Conclusion step. Therefore, the result is true for, because LHS equal to RHS, we get a conclusion that the result is true for, assuming the result is true for n equal to k, and we have to prove, we proved that the result is true for n equal to k plus 1. So, therefore, the result is true for n equal to k plus 1. So, by induction principle over, we are assuming the result is true for n equal to k, and we prove that the result is true for n equal to k plus 1. Since p of k plus 1 is also true, so assuming the result is n equal to k, and we proved that the result is true for n equal to k plus 1, therefore the conclusion step is, therefore the given result is true for all n. That is, our step is proved. This is the given result is true for all n. Therefore, our given statement is true. Therefore, the given statement or problem. Therefore, the given statement is proved by induction method. Given statement is proved by induction method. That's all about this problem. So, sum of all the squares of the odd terms or natural numbers is proved by induction method. That's all about the problem. And we will continue the problems the remaining problems in our next video. Thank you.